Through various courses as an undergraduate at the University of Victoria, I have developed a forest rendering platform to assist in conceptualizing cultural relationships to forest ecosystems. This project allows for the creation of representative landscapes to visualize ecological processes as well as the impacts of industrial development. This system enables real-time modification and procedural regeneration of vegetation, which can be used to create interactive applications. Regional GIS data for terrain, hydrology, infrastructure, forestry, and agriculture can be incorporated into this system, including the use of temporal data to create time-lapse animations. I have experimented with this platform to create informational animations, interactive art installations, and as an educational video game environment. At UVic, I have had the opportunity to engage in a highly flexible, multidisciplinary program in computer science, visual arts, and environmental studies. Moving between these disciplines, I understand how the dynamics of ecological and social systems differ from the mechanical processes that structure computer programming. My development process is through research creation, where my formal education and experiences in nature inspire intuitive creativity. I continually move between natural and structured environments, and through the corresponding mental landscapes of holistic and mechanical thinking. I have worked extensively as a tree planter, where I've experienced the intensity at which industrial logging fragments ecosystems. Through this work, I have learned how the use of mechanical abstractions, such as GIS data, have enabled extensive resource exploitation. I seek to express these connections through digital mediums, subverting utilitarian technology as visual art. In the field of 3D computer graphics, I have developed a novel technique to render volumetric details. Viewport displacement mapping uses per-column viewport subdivision to extrude additional details from coarse meshes. This method uniquely allows for the implementation of texture blending with high-frequency images. A texture-based approach to rendering vegetation allows for a wide variety of spatial scales to be represented, and for simple image filtering steps to approximate adaptive ecological processes. I have developed viewport displacement mapping specifically to render forest environments, following intuitive processes that connect this research to contemporary issues. I hope to continue this work to create applications that foster intuitive understandings of landscape-scale ecosystem functions, as well as complex human interactions with forest environments.